Good evening, everyone. Myself, Ashu Sharma. I welcome you all in series of compiler design. Today, we will see how to create predictive parsing table and what are the things that we do need to fill those all the entries that we require for all the terminals and with respect to non-terminals. So here we have this example. In this example, we have a non-left recursive expression, which is very popular expressions and the grammars that we generally use for most of the examples in this compiler design. So here this grammar and this production rules are non-left recursive expressions. So you have to just note down on your text copy over here that E drives capital T E dash, then E dash having this production plus T E dash and epsilon and having these three productions. So on the basis of this, we have one of that technique on which we may say that to create a parsing that predictive that parser table. So I am just sharing that screen, and we have to go through this method and this philosophy that how do we make this. So as an input, we have a grammar Z that we have just seen over there, and output is a parsing table capital M, and method is like these steps we have to follow. So for each production where we have this A drives alpha, where capital A is obviously it's a non-terminal and alpha is a variable, which is a sequence of terminals and non-terminals of the grammar, do the followings. The first rule is that for each terminal A in first of that alpha, add A drives alpha to M and this having that A comma small a. So this is that for each terminal, we have to just pick all the terminals, and with respect to those terminals, there will be entry that is going to be filled. So if we switch from that first production that we have this E drives T E dash. So as we know that the first of that T is having that derivation that starts from F, and F having that derivation starts from that open parenthesis and ID. So this production will go with respect to these two entries, open parenthesis and ID. So we just jump to that slide and just see what exactly the outcome of that production. So yes, we have this E dash and E drives TE dash. So these two entries just are going to be filled with respect to this capital E, which is a non-terminal. The next one is E dash. So jump to that previous slide and just to see what exactly the rule first. Now, according to rule number 2, if epsilon is in the first of alpha, then for each terminal B in follow of A, add A drives alpha to this entry M, A comma B. If epsilon is in the first of alpha and dollar is in the follow of A, add A drives alpha to this capital M and this entry A comma dollar as well. So this is the way we just use that. And if after performing the above there is no production at all in this M A comma A, then this set to error, which we normally represent by an empty entry like we have for this given table. So now we use that following that given grammar. Next one is that E dash drives that plus T E dash, this is the production, and E dash drives epsilon, this is the production. So how to put this in that case, we have to just jump to the rule number 2 and rule number 1. So here for each terminal A in first of alpha, which is a set of, which is just a set of variables, and the combination of terminals and non-terminals, add A drives alpha to M A comma A. So as we know that E dash, that the first of that is plus, so we have to just simply put that expression, that production into plus E dash drives plus T E dash, and rest of that production we have from the E dash is epsilon. So here we have this epsilon is going to be E dash drive epsilon. According to this, it will be driven if epsilon is in the first of alpha, then for each terminal B in follow of A. So follow of E dash, as we have computed, what was that follow of E dash if we just go through. So in the follow of E dash, we had this closing parenthesis as well as this dollars. So we just put these two entries over here. So this is the way these two completed. Next one is for the capital T. So for capital T, we have the same story that we just go with this. So F drives, T drives this FT dash, and F drives that opening parenthesis and IDE. So it will be over here. T drives FT dash and T drives FT dash. It's a very similar story. Then for the T dash, it's very simple. We have to check for that follow of that. So follow of T dash as we have, if we just check over here according to that. So according to that, there will be a plus and this closing parenthesis and dollar. If we check for that follow of T dash, so all these T dash stripes epsilon entries that will be go over here, and this is because of asterisk is in the first of that T dash, so it will come to be T dash stripes strict F T dash like that. So this is the way just we just complete this row as well. And the last one is because of ID and open parenthesis is the part of that first of F. So we just put these two expression over there, F drives ID and F drives parenthesized E. So this is the similar story that we have in this as we have computed all these entries. It's very interesting algorithm. As we all know that predictive parser is one of those techniques that comes under the top down. So it's a wonderful technique for that leftmost recurse, that leftmost derivation. And if we divide that parts into two parts, that one is of that top down and other is the bottom up. So in the top down, we generally have this predictive parsers type of things, and wonderful backtracking is there. So further we divide these two into two parts, is non-recursive predictive parsing and recursive. So this is the way that we just use to create this parsing table for that given grammar. So thank you very much being with me in this session. If you like these videos, please subscribe my channel. Such kind of exercise and these questions are very important for any competitive exam as well as for university exams. So you should try at home by using pen and pencil and your text copy as well. So if you like these videos, please subscribe my channel and press the bell icon so you may get the notification of the latest uploaded video. Thank you very much. Have a nice day.